So, hi everyone. My name is Bob Claerhout. I'm from the company Aloxy, and I will be presenting the way how we solved how we're trying to solve in generating an IoT platform for the Aloxy solution we're creating. And let's get started right ahead. So, as I said, my name is Bob Claerhout. I'm a Master of Applied Science in Applied Engineering and Electronics ICT, and I got graduated in 2011. And I started working for Aloxy in 2018. So, roughly working 1 year for Aloxy right now. And when I started working for Aloxy, it was my first time professional experience with Java, with containers, with Kubernetes, with OpenShift. So let's say I'm just a new kid on the block and trying to figure out everything. This is the talk I'm going to give today is about my experience from the first year, what I experienced, how I came across some things, how we're trying to solve it, and how we came, or what the actual architecture is we're using right now. Let me give a small word about Aloxy as well. Aloxy is the yellow logo on all the adopters page right now. We are using a lot of IoT projects, including Ditto, Hono, and VORTO, as seen here on the adopters page. We're a small company. We were founded in 2017, and we are a spin-off of the University of Antwerp, and we are headquartered in Antwerp as well, in Belgium. The special thing about our company is that we are not focused on the IoT platform. We are focused on integrating or creating a vertical. So we're trying to create a solution rather than just creating an IoT platform, which is an important difference because, for example, we are specialized and we are mainly focused on the wireless communication. For example, Dash 7 and LoRa. There is a lot of expertise in our company. One of the founders is also a professor in the university and is working solely on the wireless communication. We have 3 embedded developers working mainly for the wireless communication. So the focus of our company is actually rather on the wireless side of the solution. The only one backend developer is standing in front of you. I'm just the only one, and we're obviously looking for colleagues. To be honest. This month, I think we found someone. He's coming over from Portugal, and we will be 2 next month. But besides that, we are still looking for colleagues. So if you're looking for a job, come and visit me. Then some technicalities. In 2018, we raised 2 million euros to get things started. And we are just, we're working with companies such as Dow, BASF in Ludwigshafen as well, NG Fabricom, Solvay, and others. Also, we are a proud contributor to Eclipse Hono and Eclipse Ditto. VORTO is not on our list yet, but yeah, we will try to contribute as much as possible. If we find the time and if we have, don't not have anything other to do regarding customers and stuff like that. Then a little bit more about what we call the Aloxy Pulse. So let me first get to explain what vertical solution we are trying, or what vertical problem we're trying to solve with our solution. And in order to solve it, we have created a sensor. We call it Aloxy Pulse. It has temperature sensors. It has a magnetism sensor. It has vibration sensors. It is able to position itself and detect the orientation. It has buttons, it has LED sensors, LED lights, so quite everything to make sure that we have a versatile sensor which we can use in multiple scenarios. And the first scenario we're trying to solve is the positioning of manual valves, and that goes for quarter valves, multi-turn valves, and we're trying to solve these problems over here. So we are trying to obtain valve statistics. We are trying to receive alerts. We're actually receiving alerts when, for example, it's manipulated when it's not supposed to be. We are trying to ensure that the valves are in the correct position and stuff like that. And actually, we're trying to make sure that every customer who has a problem is able to solve the problems with this sensor. Of course, the problems cannot only be solved by using the sensor. We need to use an IoT platform, and that's what we are here for. And these are a couple of examples on which problems we're trying to solve as well. So the maintenance progress monitoring is, for example, when a chemical plant goes into shutdown, they are trying to dismantle plant, and they're moving it so it can get cleaned, it can get fixed, and yeah, do a lot of stuff we don't know about. But to track all these devices and to make sure that they can keep track of all the devices and make sure that it's not getting a mess in chaos, we can offer a solution to make sure everything gets in place, and the problems, for example, of valve not getting back to the plant are detected before they're starting up instead of just at the minute they're wanting to start up. An important one over here is the question mark. The question mark is mostly important for our IoT platform. We want to make and create an IoT platform which solves this vertical problem, but also is able to solve problems we do not know about. So other customers can just raise and make have their own problems in trying to solve using our IoT platform. Now the important part, the IoT platform itself. This is our main setup, just a global overview. So we have the sensor, we have private or public networks. The private network is, for example, our own gateway using LoRaWAN or the -7. -7 is a technology created on the University of Antwerp, and is also an open source technology. And then we have the public networks, LoRaWAN, Sigfox, for example, using the public LoRaWAN server providers. They all communicate via through the or to the Aloxy IoT platform, and the Aloxy IoT platform on its turn communicates to, for example, our application, our Aloxy application, the manual valve position as we call it, and then the device management or even other customer system integrations. What do we need for our IoT platform? What are the requirements? Most customers request an on-premise installation, which is a really hard one. In the next slide, or in the coming next slide, there's an overview of some of the existing IoT platforms, and a lot of them are falling off the list because of the on-premise installation. It's a really important feature that we require. Our customers require it. We do not require it. We would like to install in the cloud and just have all our customers in the cloud. But our customers demand that we install on-premise, and that's a very important one. Besides that, we want to run it in multi-cloud. Some users, some customers want to run it in our own cloud. Some users want to run it in a hybrid cloud. Very important as well for our cloud installation. We want it to be multi-tenant or multi-instance. And then a very important line for this EclipseCon as well. We do not want to reinvent the wheel. We want to reuse what's there already. We want to use open standards. We want to use open source as much as possible. The main advantages for this is towards our customer. Say, for example, Aloxy changes route or changes, for some reason we do not want to use the open source anymore. When we install an installation at the customer can, for example, make sure to have it supported by other companies using also those open standards, or can even get people trained to use the open standards and use them. We want it to be scalable and fault tolerant, of course. We want it to be extensible. We wanted to have an open gateway and device API exactly for the same reasons, so that the customer doesn't have to be using a black box and just can use whatever is there. We wanted to have an open application API exactly for the same reason. So a lot of open in this slide, but yeah, that's the main reason why we're here. That's the main reason why we're open source using, and we're at EclipseCon. So this is a comparison of a lot of IoT platforms, or some of the IoT platforms, of which, as I said before, the on-premise line, the first line, is a very important one. And you see that already Siemens MindSphere, for example, or the managed cloud providers are already falling off the list. Thingsboard and Mainflux were on the list, but lack maturity and off-the-shelf capabilities, for example. So that's the reason why we came for Eclipse IoT, and within the Eclipse IoT we chose for Hono and Ditto, and we are very pleased with the choice. So yeah, let's continue and have somewhat of a dive into the IoT platform. Before I started working at Aloxy, this was a state, and you have to know, for example, that Aloxy is mainly focused on the verticals, so they are trying to solve a solution. And the solution was solved by doing this. We had some proof of concepts, they were working. There was a main focus on the wireless communication, main focus on the gateways, on the sensor, and they all developed this using a simple backend application, which just consisted of an MQTT connection towards the Aloxy platform which used to be Mosquito as well, the broker. And the Aloxy platform was just working in Python, consuming the messages, putting it in MongoDB and in FluxDB. And afterwards, there were some customer integrations, just as Modbus integrations, for example. It all was working. Nothing was failing. It was the customers were happy. Everything was working as expected, except for the fact that if tomorrow, for example, we would connect a lot of more devices and get out of the POC phase, yeah, we would have a problem. So we want to have it scalable. We want to have it, reliable, just like the other slide I mentioned before. So that's how we came up with this. This is the current situation. So now we are connecting to Hono, and after Hono, everything is communicated to Ditto. Ditto is making use of Keycloak now, and then we have our Aloxy MVP application, which is consuming the messages from Ditto and putting them in timescale and back in Ditto as a digital twin again. After the digital twin, we have MQP communication, WebSocket communication, or MQTT communication to make sure that the Modbus integrations, for example, at customer side work, and we can make sure that the data flows back into the systems of the customer. All of this is running with OpenShift, and LMAS is the communication layer in between every service. Then we would like to have, we are currently working on this situation, so we are incorporating VORTO as well. And let me just go back and forth a bit and see what the differences are. So VORTO is coming into the picture. And then we would like to make a time series API as well, because currently we're using Grafana just to visualize AL data, but we also want to give the customer the possibility to call an API to get the historical data. That's not the case right now. They just have a dashboard from Grafana, and that's about it. And then in between Hono and Ditto, we would like to have a normalizer somehow, and this normalizer is using VORTO. And the rest of the architecture is more or less the same, if I'm not mistaken. Yeah, okay. Then for the people in the room who do not know the Eclipse IoT project, I will give you a brief overview of what the Eclipse IoT projects are, what they do, and what our experience with it, and whether or not we contributed as well. So let's start with Eclipse Hono. Eclipse Hono is the one component which is responsible for connecting all devices. So we use this to connect LoRa1, the public LoRa1 server, for example. We use this to connect our own private gateway. We use this for HTTP communication, and Hono is capable of doing all this: multitenant, secure, scalable, and all of these things on the list. And we would like to congratulate the team for releasing version 1.0 last week. It was very busy on the mailing list and on the GitHub. We would like to congratulate everyone. Then Bosch and Red Hat are the most active contributors. They have bi-weekly calls, which we follow or try to follow as much as possible. I personally love those calls. It keeps you up to date without reading all the emails or following every ticket in the GitHub page. We can just follow everything by just calling in and get to know what's moving on and going on within the community. It's very mature. We have fast jitter, Stack Overflow, and GitHub responses, and they are willing to contribute from downstream. For example, the LoRa adapter wasn't in the Hono update upstream repository, and they contributed from downstream, which is nice because we can use it, and we are contributing to that LoRa adapter right now. And those are the small contributions we did to Hono. Also, we had a face-to-face in Berlin, which was nice as well, to get to know the people, just like here on EclipseCon, get to know people, make sure that you're in contact with them, and all good. Next phase, or next component I would like to discuss is the Eclipse Ditto. Eclipse Ditto is a digital twin. It is we use it mainly because it has a standardized HTTP API and a WebSocket API ready for the customer to use. So that means we just flood in, provide all the data to Ditto, and the customer can filter and use the data as he likes, and then more or less that's it. It doesn't have much talking about, or you can't talk about it much, but it does what it needs to do. and we're happy to use it. We had some minor contributions on this project, a little bit less than in Hono, but we had some, and yeah, we're still proud of it. It's becoming mature. I think they're working towards version 1.0 right now. Bosch is also the most active contributor in this, and currently there is no community call whatsoever, but maybe it would be nice to have it just to get the community going and get some more contributions from other companies as well. Besides that, Jitter, Stack Overflow, and GitHub are also closely watched, and you get fast responses as well, which is a good thing from the team. Then VORTO is somewhat of a different story. We are not yet using VORTO that much. We are trying to, but we're still seeing whether it fits our needs. It provides a simple language to describe every object. For example, if you have 10 different sensors using temperature, then you would describe the temperature always in the same way, so that, for example, the customer, when he subscribes to a temperature sensor, he just receives the temperature always in the same way. So, for example, our Aloxy Pulse is sending temperature as well, but it is sending it in a different way than any other LoRa adapter is doing. So, by using VORTO, we can normalize the data and present the temperature always the same way. You can share these and reuse these descriptions, and it also is able to generate some code. As I said, it's also used by Aloxy Pulse, and yeah, as explained, only the customer needs to integrate once.
How is it used by Aloxy Pulse? What is Aloxy Pulse?
So we are parsing the data in the backend server, and then the Aloxy Pulse uses the temperature model, for example, to present its temperature just the way as any other LoRa sensor which measures temperature.
I thought Pulse was the sensor.
Yeah, it is using this. Yeah, so yeah, it is poorly written. That's true. But the Aloxy Pulse is sending data in binary way and not in a JSON way, and we are parsing that and presenting it using the VORTO model.
But so that is not happening on the sensor.
No. Yeah, it's happening on the backend. Yeah, it's true. Yeah, but actually, it should say we have created a VORTO model for the Aloxy Pulse. Yeah. What's our experience? Bosch is the most active contributor. It has no community call right now, just like Ditto. Might attract new contributors when there is a community call. It is not as active as the others, but they are reachable by Jitter, Stack Overflow, and GitHub as well. And we currently didn't have any contributions, but as I said, it's fairly new to us, and we're still gaining some experience. Then en masse, not in the Eclipse IoT group, but I think it's worth mentioning because yeah, it serves our needs for our backend application. Right now, it's messaging. It provides AMQP 1.0 communication. It's multitenant. It's also providing some authorization. It's a pub/sub request response mechanism. Then Red Hat is the most active contributor in it. There's also no community call, if I'm correct. Yeah, I'm correct. But it is fast-paced. It is a fast-changing project. It goes, yeah, it's rather some magic to me, but it's fast-paced, and there are a lot of iterations on it, and they are reachable via mailing list or IC. Not my personal preference. I rather like Jitter or Stack Overflow or the Jitter or Stack Overflow indeed. And then we didn't have any contributions so far, but yeah, like as I said, it's a bit of magic to me right now. Then Keycloak is also used within our project. It's also an open source project, and also from Red Hat, and it's an identity provider. I think most of you would know what it is. Single sign-on is useful for that, and yeah, OAuth and OpenID are the most important features to that. We use it for securing our Ditto frontend, and eventually also the API calls are secured via Keycloak. Then we're not following in this community at all, but it is open source, so if you want to dive in, you can. It does for now do what we need to do, so that's it. So that's what we're currently working on. However, we are not stopping after that. We will have to change some other stuff as well. and we will try to incorporate these changes. I will go back and forth a few times to just let's see what changes. So VORTO is currently used within the normalizer in our application, but we would love to see that the normalization of all data happens in HONO itself. So, for example, the LoRa adapter is able to, depending on from which public LoRa network server it comes, to parse the data differently and to normalize the data. Maybe it's possible to have this VORTO integration within HONO, so to make sure that every data coming out of HONO is normalized already. Then we are actually incorporating a LoRa server in our IoT platform as well. And we would love to incorporate Hogbit as well, but we do not know whether it's communicating right away with Hono or via Ditto. And then IOFOG is coming into the picture as well. So just go back and forth once more. So here at the bottom, Hogbit, IOFOG is coming in the picture, the LoRa server, and then VORTO is shifting up to Hono. That's currently our goal, so we're working towards that. LoRa server is an open source implementation of the LoRa network server you're used to. So, for example, the Proximus LoRa server or the Digimono LoRa server, they are all implementations of a LoRa protocol or LoRa network server. And LoRa server IO is an open source implementation of this. And we would like to place this behind Hono just to regulate the network, the LoRa network on site. And it's just to have a brief overview of it, it's just determining how a sensor should send, for example. So there's a spreading factor, for example. The LoRa server determines how good the message came through, and then says to the sensor, next time use this spreading factor because of that or that or that. That was a brief overview of the IoT platform itself. Of course, we need to deploy it as well. For deployment, we're looking to cloud native deployment. All of these, these are all the reasons. So scalability, microservices is most common. You're on EclipseCon, so probably you already know a lot of these reasons. We are following this approach, and we are also using this slide towards our customer because they are not aware of all the cloud native developments. So we would like to incorporate this in our slides and make sure that the customer is with us on this and also follows our way of working. We're deploying on Kubernetes. Currently, we're also deploying on specifically deploying on Red Hat OpenShift. Kubernetes itself is the de facto standard, and also Gartner and is stating that a lot of enterprises will be using Kubernetes in the coming years. So we do not doubt this, and we are just following the mainstream and using Kubernetes as well. It's a standard way to package and deploy our applications, and we will probably, if we use, for example, IOFOG in the future, it might be that we will be using Kubernetes just to extend to the edge as well on our gateways. Then, as I said before, a really important part of our IoT platform is that we would like to deploy on-premise as well. And for this, we have a slide provided, which is more or less comparing the different solutions we have. So it goes from on-premise just until cloud managed multi-tenant situation. And we would like to give the customer the opportunity to choose which fits best their needs. So for the ones who are really scared of cloud, we have an on-premise installation. We try to avoid this as much as possible, but some customers just don't want it and demand an on-premise installation. But they have to be aware of the fact that it will be very expensive, and it will be a higher subscription cost, because we cannot share the subscriptions. For example, on an OpenShift cluster, they have to have their own subscription, but they have a very good data isolation of it, and there is a good integration with the DCS as well. Although I have to mention, for example, that when we want to have a DCS integration with a cloud installation, we just have one part of our cluster running on-premise, which communicates via the Ditto API, through WebSocket, HTTP, MQTT, AMQP, to get the data in the data in the on-premise again, and then provide it to the DCS. So it's more or less the same, except for the fact that the DCS integration is the only server or service running on-premise. And then we lower the installation cost based on how much you want to go into the cloud. As I said before, we're trying to get as much as possible our customers into the cloud, but that's not always the case and not always possible. So this is a nice overview of where we want to deploy. We want to deploy, be able to deploy on all public clouds if possible, and if not possible, just on bare metal. But OpenShift for now is standing just in the middle, and we're trying to use that as a deployment, deployment mechanism and deployment, our deployment platform. So that's about it. So what are the key takeaways for our IT platform? We want to prevent lock-in. Our main entry points publicly are Hono, Ditto, and VORTO, and they are open source, so you can reuse them or implement them yourself. We are integrating multiple networks, of which Dash7 and LoRaWAN are two examples, and we are focusing on it as well. But we're enabling third-party LoRaWAN as well. Then we want to normalize the sensor data so that that does not depend on which sensor is sending the data, that is different data or different structured. We have a powerful digital twin API for presenting all data. We will integrate a LoRaWAN server in the near future. And we want to, one of the reasons why we are, one of the key features we are different on is that we want to improve the device and the network monitoring on-premise as well. So that's something we differentiate on. Because of our focus on wireless technology, we actually want to show to the customer how the network is performing, and we want to make sure that we can make suggestions on how to improve the network or change the network so its application is working better. We also are analyzing all the data to make sure that we have a better quality of service for battery latency and scalability, including the LoRaWAN services. So and then we want to have an on-premise deployment possibilities. So right now we have a solution, vertical solution, and we want to grow into a generic IoT platform. This is actually the goal for me as a backend developer. For Aloxy, we're trying to create the vertical so we get customers and get everything rolling, but the IoT platform is actually meant to be broader and meant to support a lot of use cases. Then some next steps for the IoT platform and maybe some Eclipse IoT projects. Hono, we would like to implement the LoRaWAN downlink adapter in the Hono adapter. We want to have to normalize, as I said before, the data within Hono, so every data comes out of Hono exactly the same way. And we want to deploy InfiniSpan as well, which is already in version 1, I think, but not yet deployed in our cluster. Then for Ditto, we want to have the current and the desired state, so it gets automatically updated towards the device via a downlink command. For VORTO, we want to deploy our own repository. To be honest, last week I did the deploy, but we want to incorporate it more. We want to have more mapping. We want to have more normalizing from VORTO. And then Aloxy itself internally, or maybe the managed API can be made open source as well, depending on how generic we can create it. We want to create a management API, and we have more alerting and monitoring, but that's internal things. If we go on premise, for example, then we need our own, so there is no specific reason, but if you go on premise, then we don't have a choice.
They wouldn't even allow it to fall out to such a service?
No.
You simply would use them?
No. So in the chemical companies, they have what they call sort of layers, and data can go out of a layer, but can never come back, just for security reasons. And the lowest level of data is for example, valves. I'm just guessing right now, but the valve information. And once that valve information, for example, is that open, that is the open percentage right now. It won't come down. For example, to say, oh, we want to blink a LED because that's the valve you need to operate. No, that's not possible.
So how do you install VORTO, the VORTO repository? Is that a big thing to do?
Currently, it's just a YAML file. I think just install it on the in cluster as well. It's just a Docker file. Yeah. So fairly easy. Any more questions? Yeah.
As far as I know, IIoT is a dedicated or mainly designed for deployment.
Yeah.
Which is Hono as well. So what is your idea to combine them both?
If I'm correct, Heartbeat is indeed a way to update your installation, but you have to do indeed the initial installation can be done with Heartbeat. So it has a client running which polls the server of Heartbeat and then requests whether there is an update or not. Second, as I thought we were just talking about it, a few seconds ago. It seems that you can combine Heartbeat and IOFOG together, and just Heartbeat saying there is an update, and use IOFOG to install the update on the device.
So
but
IIoT as a client for
No, it's the other way around. Heartbeat is mainly used to design your rollout campaign, where you have, for example, but doing the rollout itself is not what Heartbeat does, but it can integrate with other systems that do the actual installation. So there is no standard Heartbeat client for a device that you can use to install your software locally, but you have to know how that is done yourself. And in that case, IOFOG comes into the game because they know how to install the software on the agent.
So IIoT runs as a client for Heartbeat.
Not really as a client, but it is integrated with Heartbeat via their backend integration API, and Heartbeat controls the rollout via IOFOG's API.
Yeah, but we're not using it right now, so we're looking into it, and we'll probably have this exact same question later on.
Why did you switch from influx to timescale?
Why did we do that? Good question. Do not know the reason right now. I've looked into it. I don't know, Glenn, do you know? Do you remember?
I think we had some relational data as well, and we wanted to join the
Yeah. So maybe for the rest of us, we had some relational data and we wanted to join it as well. So we had some, for example, when you're having a logical name, which is only available in Ditto, we wanted to have it in the Postgres database as well. Yeah.
Okay, thank you. And we're coming back on the update. I was curious. So those devices, for example, that you install on Valve.
Yeah.
Have you talked about updating the firmware on those using update and stuff like that?
Yeah. So yeah, that's part of the plan. Yeah, so we have the gateways on site. Our own gateways on site can be updated via Heartbeat, and then in some way we should be able to use Heartbeat as well for the devices as well. But yeah, as I said, we have to look into that and see what the possibilities are. Anything else? Okay, great. Thank you very much.